Hello everyone. So in the third part of this lab, we want to learn how we can create a pie chart and histogram. So in this case, we learned that how the bar chart or bar graph is for the categorical data. So the second graphical display for categorical variable is pie chart, and we want to see that how we can create that with RStudio. So this time we want to use another data set, the data set of exam. So the exam data set, as you see in your directory, the exam is in the Excel file. So if you want to view it, so we have two variables, grade and count, and it's a grade of the students, I think 80 students, grade A, B, C, D, F, and of course the number of students with that grade. So in this case, I want to, first we need to read the data set, or we need to import it, because the CSV, the type of data is a CSV Excel file, so we need to use the command read dot, look here, we need to use the command read.csv, and the file, of course, the name of the file, because it's in our directory, we don't need to provide a path to the data set. And because it's a CSV file, in the CSV file, if you see that the data set are separated by comma. So that's why you need to determine sep equals to comma, and the first title of the data set, the first row of the data set is the name of the variable, so that's why we need to determine header equals to true. So in this case, what we read the data set and save the data set into my data. So let's run this line. So you'll see that here we run the data set. Now if I say that my data, type my data here, you'll see that you have the 5 observations, 5 rows, and 2 variables. But still you can use the head and give the data set. It shows you that you have this data set. But I want to create a pie chart. So because the grade and the count, there are 2 variables saved in my data. So if I want to have access to the count, I have to use the $sign. So pie, my data, and the variable saved into my data. So it becomes my data $sign count. And if I run this command, so it gives us the pie chart of the data set, of course, then the pie chart. But we want to use the same trick we did in the last part. So I don't want to use always $sign to access the variable. So I attached the data set. So now I have access to everything inside of my data. So I can call it. I don't need to use the $sign again and say that these local variables are saved into this data set. So I say that pie counts exactly the name of the variable. And then the label here, we say that, do you remember in previous pie chart, the labels are just the number of classes, 1, 2, 3, 4, 5. But I'm going to, it is not informative. I want to show that labels are grades in this data set. So that's why labels equals to grade, the first variable. So when you run it, so that's why you'll see that we use the first variable as the labels, and that's why not only it shows you that the share of each category, but also it gives you the label of that category as well. But sometimes it is not enough for us. I want to see that, not only see the proportions or share of each one, but also I want to see that the number of the individual in each category. So in this case, this time we can change the labels, and label equals to exactly the data set of we are using, count. So by running this data set, you'll see that it gives you the same pie chart with the same categories or share of the category, but also this time it's labeled by the number of observations falling in each category. But sometimes I may find that this, okay, I have the pie chart, but unfortunately I want to see that the proportion of observation in each category, because right now I just see that the numbers. So what I can do, we can create a label by hand. So each count variable, here we have 20, 13, 10, 5, and 2, divided by sum of the total number of observation in this data set. And then we save it in my label. So if we run my label, so here you'll see that, and then if we showed my label, so look at this, the number of observations with grade A is 20 out of 80 observations. So that's why this is the 40% of the, I think it is not 80%, is it? It should be less than that. So the proportion is the 40% of observations are in category 1, category A, 25%, 26% are in the category B, and 20% they are in the, there are 40 observations, sorry. So the 20% of observation are in the category C, and so on. So now I want to again pie chart, create a pie chart of count data, but label this time equals to the label we already created, proportions. So if we run this line 100, so we run it, so we'll see that now we have access to the data set. Sorry, we have the access to the each category, and we also show the proportion of each category. Sometimes it is not enough for me, and I want to have I don't like the colors. I want to change the colors, so that's why you have 5 categories. So you can check this one, rainbow 5, or you can create one by one the color that you want. So here, when running this one, so you get the rainbow colors, the first 5 colors. And then you can also add, at the same time, I want to have the label of the grade as well. So the copy here, and then the label should be the name. And now if you run it, so we have the label of the categories. We see that the share of each category and with the different color. Because we have worked with the data set, I don't need the data set anymore. I don't need the access to the variable in this data set. So I detach this data set, and that's it. So the last topic which we want to cover in this lab is histogram. In the histogram, what we want, by the way, something that if you're working with R Markdown, sometimes you want to revise it. You don't need to run the entire R Markdown. So there is one green triangle here. If you run it, so it runs only these R chunk for you, and it doesn't run the previous each time. Of course, if sometimes your R codes are calculation, you don't need to want to calculate them each time, all the chunks. Anyway, so this time I want to create a histogram of the data set. Again, we revisit the reverse data set. So the reverse, we have the 141 of the reverse, and now I want to make a histogram of the data set. The command is very simple. It's hist data set, name of your data set. So if you type this one, now it gives you that the histogram of your data. But we want to learn more options about it. If you see that there is only one, there are, I don't know how many, because R recognize, R automatically select number of classes and creates the histogram. But I want to be able to change the number of the classes. So because we have 141 observations, so I would like to have the 21 classes. So in order to have 21 classes, I can use the option bricks. Bricks equals to 21. It means that make a histogram for me with the 21 classes. And when we run it, you'll see that you have the histogram of the dataset again, but this time you have the 21 classes. Unfortunately, this 21, it means that it's not very good because you have many empty classes. But the next thing is that I want to, not only I want to determine the number of classes, but I want to determine the thresholds or the lower bound and upper bound of each class. So that's why I create a new vector. I call it, I want to have the histogram with 5 classes, such that the first class is from 0 to 1000. The second class is from 1000 to 2000, 2000 to 3000, and 3000 to 4000. So I determine the values in B vector, and then this time I type with histogram of the rivers, but bricks equals to this vector we just created. And if you run this line, so you'll see that you have the histogram of the rivers. So the first class from 0 to, the same thing we determined, 0 to 1000, 1000 to 2000, and the same. Or sometimes I want to have, I think the number of classes is not in, I want to have more classes. That's why, so I can use the command sequence from 0 to 4000, and then here increase each time by 500. So, and I call this one B vector 2. So B vector is now, it's that from 0 to 500, 500 to 1000, 1000 to 1500, 1500 to 200. So it increases 500, 500 units. So now I want to recall the brick equals to this sequence that I created. I want to have this sequence to be the lower and upper bounds of each classes. So type histogram reverse brick equals to B vector 2, and of course it is the histogram from 0 to 500, 500 to 1000, the same thing that we determined. So we have many flexibilities, or sometimes you can create a sequence from 0 to 4000 but divide them to 7 observations. So B vector 3, so you look at B vector 3, it creates the 7 observations, a sequence of 7 observations between the 0 to 4000. So of course equally spaced, so 0 to 666, and then this one to the next one, and then you want to recall this one as the number of classes, and the same thing. But of course I don't like this one because 666 and it has a decimal places. I don't recommend it this way. I think B vector 2 was the best one. So now I select that histogram reverse, but B vector 2, and then I want to change the color. I don't want it gray. I want to have another color, for example, red. So now we determine option col, COL equals to red, the name of the color inside the quotation, or you can change it to whatever you want, green or blue. I encourage you not to change to green because green is not a good color in the screen. So blue, for example, what I want. The next option is that I want to be able to change these labels. For example, you see that histogram reveal. I don't like this title. I want to change it. So what I change, I wanted to add it to main equals to quotation. For example, I want to say that distribution of rivers. So you can run the code. So let's change it to red. Where is it? Yeah, red, and then the title becomes the same as we identified, distribution of rivers. I also want to change the X label. So here X label becomes X lab equals to, you can call the rivers data set. Rivers data set. And then if you run it again, So you have the same histogram, you change the title, you change the X label, even you can change the y-axis, but I encourage you not to change it. So the last thing we want to learn is that histogram. We learned two types of histogram in our class. One of them is frequency histogram and the other one relative frequency histogram. By default, create histogram that the y-axis is the number of observations in each class. That's why it is frequency. So we have 80 observations in the first class. So that's why fric is the command that we can change it. So if fric equals to t, so that means that I'm interested in a histogram, frequency histogram. So it creates for you the frequency histogram. But if you change it to fric false or fric if, so the histogram, if you run this command, so it gives you the distribution. In other words, the relative frequency of observation in each class. So it is the distribution of the histogram. So today, that's the end of the lab 5. So this is the first part of data analysis. So in the next computer lab, we talk about the regression and 5-number summary, mean, standard deviation, and scatter plots. Thank you for your attention.